we are ready to simulate and view our fuzzy logic system. To do that, we will first open the rule viewer. For that, we will go to the View menu and select Rules. This opens Graphical User Interface number 5, Rule Viewer. Each column here shows the set of membership functions for a particular input. So we have 3 membership functions for our service input, 2 membership functions for a food input, and 3 membership functions for our tip output. Each membership function in this set is associated with a particular rule and maps input variable values, service quality and food quality, to rule input values. In other words, the number of rows here is the number of rules that we have. The first row corresponds to the first rule, second to the second rule, and the third row corresponds to the third rule. The plots in the output column show how the rules are applied to the output variable. The bottom right plot shows how the output of each rule is combined to make an aggregate output and defuzzified value. The red line provides a defuzzified value, the tip amount, that is our answer. We can slide the red lines to change input values and generate a new output response. The input values are shown here, service of 261 and food of 814, and their corresponding output value is shown here. So the answer that we get is tip is 18.3%. Also, the values of membership functions for our inputs are shown graphically by the yellow highlighted areas. We can also type in the values of inputs explicitly in the input box and test our fuzzy logic system that way. Another way to look at our fuzzy logic system is to open Surface Viewer. The Surface Viewer displays a surface that represents the mapping from surface quality and food quality to tip amount. For fuzzy inference systems with more than 2 inputs, you can select any 2 inputs and any 1 output for plotting. In this case, we only have 2 inputs and 1 output, so that's what we see here. This is the mapping that we were trying to create when we saw one of the very first slides in this demo. And as you can see, it does exactly what we wanted. It shows high value of tip for good food and good service, low value of tip for low food and low service, and the big flat area in the middle corresponding to the average tip amount. We can rotate this plot to see it better. We can also plot the output, the tip amount, against just one input, service or food. To save the fuzzy inference system to MATLAB workspace, we can use File menu and Export to Workspace. Define the name of the variable that you want to save your fuzzy inference system to and click OK. Now we see that this fuzzy inference system is in our workspace, and this variable is now available for further analysis with command line functions. To summarize, Fuzzy Logic Toolbox provides easy-to-use interface for applying modern fuzzy logic techniques. It lets you perform fuzzy logic control and identification. It easily integrates into model-based design through use of simulink blocks, and it provides the ability to generate code for various uses. And it supplies a fuzzy inference engine that can execute your fuzzy system as a standalone application. This concludes the demonstration.